Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In this session, we will discuss LTC MPL Physics Unit Test 7. So let's start with question number 1. A shunt of resistance 1 ohm is connected across a galvanometer of 120 ohm. So this is 120 and this is 1 ohm. Current is 5.25 ampere and it gives full scale deflection in the galvanometer. The current that will give full scale deflection in the absence of shunt is nearly. So we need to find Ig. So we know that Ig into G is equals to I minus Ig into S divided by, that's the equation. So Ig into G is equals to Is minus Ig into S, right? So Ig into G plus S will be I into S. So Ig will be Is divided by G plus S, right? So I is 5.5. S is 1 divided by 120 plus 1, that is 121. So approximately this will be option 4. Question number 2. The frequency of the charged particles circulating at right angles to a uniform magnetic field does not depend upon. So frequency is QB upon 2 pi m. So it does not depend on the speed of the charged particles. So correct answer is option 1. Question number 3. We have two long conductors separated by distance d carry currents I1 and I2 in the same direction. So force between them will be force of attraction. They exert F force on each other. So F will be mu naught I1 I2 divided by 2 pi d. Now the current in one of them is increased to 2 times. Okay, and its direction is reverse. So let's say it is 2 I1 with reverse direction and this is I2 and the separation is 3d. So new force F dash will be mu naught into 2 I1 into I2 divided by 2 pi into 3d, which is 2 by 3 times F. But its nature is also reversed. Now it is repulsion because direction is opposite. So correct answer is option 4. Question number 4. An ideal monoatomic gas at 100 Kelvin expands adiabatically to 8 times its volume. So we know that T1 V1 power gamma minus 1 is equals to T2 V2 power gamma minus 1. What is the final temperature? So T2 will be T1 into V1 upon V2 power gamma minus 1. T1 is 300, V1 is V and V2 is 8V. Gamma for monatomic is 5 by 3 minus 1. So this is 300 into 1 by 8 into 2 power 2 by 3. Right, so this will be 300 divided by 4, which is 75 Kelvin. Question number 5. During an isothermal expansion, a confined ideal gas does 150 joules of work against surroundings. So work is positive and this is isothermal expansion. That means delta U, change in internal energy, is 0. So delta Q, that is heat provided, is equal to complete work done, right? So over here it is positive. That means heat is being given to the system or to the gas. So correct answer is option 4. Question number 6. An ideal gas have molar specific heat capacity at constant volume. CV is 3 by 2R. What is Cp? So Cp is Cv plus R, which is 5 by 2R over here. So correct answer is option 2. Question number 7. Carnot engine absorbs Q1 is 750 joules and T1 is 147 degrees Celsius, which is 147 plus 273. So this will be 420 Kelvin, right? Now, it rejects 500 joules of heat to the sink. What is the temperature of the sink? So, we know that efficiency is Q1 minus Q2 divided by Q1 is equals to 1 minus T2 upon T1. So, over here, Q1 minus Q2 is 750 minus 500, 250 divided by Q1 is 750, that is equals to 1 minus T2, which is temperature of the sink divided by temperature of the source, which is 420. So after solving this one, you will get T2, which is 280 Kelvin. Right. So after converting into degrees Celsius, you will get correct answer is option 3. Question number 8. Gas is taken from A to B to C to A as shown. What is the net work done by the gas? So work done is equal to area of the PV diagram and this is cyclic process. So it is a clockwise cycle. So work done will be positive, which is equal to half base into height. Base is 2275 into 10 power minus 3. Height is 226, so it is 4 into 10 power 5, right? So this will be 1000 joules, which is option 3. Question number 9. 10 liter of water per second is lifted from well through 20 meter and delivered with velocity 10 meter per second. Then the power of the motor is, so power is energy upon time. So over here energies are mgh plus half mv square. Divided by time over here is 1. So after solving this one, you'll get power as 2500 watt, which is 2.5 kilowatt. Question number 10. If the man speeds up by 1 meter per second, his kinetic energy increases by 44%. His original speed in meter per second is. So initial kinetic energy is half mv square. Now, if the speed is v plus 1, then new kinetic energy will be 44% more than the previous one, which is 1.44 times half mv square. So we half m cancel. So we have v plus 1 whole square is equals to 1.44 v square. So it is v plus 1, which is 1.2 v. And after solving this one, you'll get v as 5 meter per second. Question number 11. A truck accelerates from v to 2v. So work done is change in kinetic energy, which is half m into 2v square minus half m into v square. So it is half m into 3v ka square, which is 3 times half mv square, which is 3 times the kinetic energy required to accelerate this from 0 to v. Right, so work done or kinetic energy to accelerate it from 0 to v is k. So work done over here will be 3k, which is option 1. Question number 12. A body thrown vertically upwards attains maximum height h. At what height will its kinetic energy be 75% of its initial value? So it's a total mechanical energy is mgh, because at highest point it will have only potential energy, which is mgh, and that is nothing but its total mechanical energy. So at certain height h dash, 75% will be in the form of kinetic energy, but remaining 25% will be in the form of potential energy. So 25% of this total mechanical energy is in the form of potential energy, and let's say that is h dash. So over here h dash will be h by 4, which is option 2. Question number 13. A ball of mass m moving with the velocity v collides head on with another ball of mass m at rest. If the coefficient of restitution is e, then the ratio of the velocities of the first and second ball after the collision is. So we have a ball of mass m. It is moving with velocity v, collides with another ball of mass m at rest. If the coefficient of restitution is z, then the ratio of the velocities of the first and second ball after the collision is. So let's say after collision its velocity is v1 and its velocity is v2. So over here v1 will be m1 minus e m2 divided by m1 plus m2 into v1 u1 plus 1 plus e into m2 divided by m1 plus m2 into u2. So it is just 1 minus e into v by 2. Similarly, v2 will be same 0 plus 1 plus e into m2 divided by m1 plus m2 into over here it will be u1, right? So this is 1 plus e m1 divided by m1 plus m2 into u1. So this is 1 plus e into v by 2, right? So ratio will be option 1. Question number 14. Two objects of mass this and this are released from separation 10 meter and move towards each other under mutual gravitational force. The acceleration of the center of mass of their system when they are 3 meter apart. So when net force is 0, acceleration of the center of mass will be 0. So correct answer is option 4. Question number 15. We have this system and we need to find the moment of inertia about this CD, right, which is perpendicular to OA. So this is A and this distance will be A by 2 and moment of inertia of this one will be 0. So over here it is MA square plus M into A by 2 whole square, which is 5 MA square by 4. So correct answer is option 4. Question number 16. We have a solid sphere is rolling without slipping on a horizontal surface. So rotational kinetic energy will be half I omega square, which is half into this divide into this, and translational is half mv square. So rotational over here will be 1 by 2 mv square into 2 by 5, and translational is half mv square. So if you take the ratio will be 2 by 5. Question number 17, we have automobile engine develops 100 kilowatt power and it is equal to tau into omega. So tau into omega is 1800 rpm. So this is 2 pi into 1 upon 60 into rpm value, which is this one. So after solving this one, you'll get the value of tau as 10 power 4 divided by 6 pi Newton into meter. Question number 18. A helium nucleus make full rotation in a circle of radius this in 2 seconds. The value of magnetic field be at the center of the circle is, it is mu naught I upon 2r, right? So mu naught upon 2r, I is, this is helium nucleus, so charge will be 2 times proton divided by time. So this is the current, so this is mu naught into 2 into 1.6 into 10 power minus 19 divided by 2 into r is 0.8 into time is 2, right? So this will be mu naught into 10 power minus 19. Question number 19. A charged particle travels along a straight line with the speed v in a region where both electric and magnetic field are present. If it is traveling in a straight line, that means QE should be QVB and both of these fields should be perpendicular. So magnitude of E should be equal to V times magnitude of B. So correct answer is option 2. Question number 20. The average EMF induced in the secondary coil is this one when the current in the primary coil changes from this to this. What is the mutual inductance? So M over here will be 0.5 divided by di by dt, which is 2 divided by 0.1. So over here this will be 0.025 Henry, which is option 1. Question number 21. We have a rod of length L rotates with uniform angular velocity omega about an axis passing through its middle point with the normal to its length tk. Okay, the induced EMF between the two ends of the rod is. So induced EMF between the two ends of the rod will be 0 because the polarity will be similar, right? So induced EMF will be d phi by dt. So let's say this is L by 2. So area swept by this rod in one complete rotation will be pi L by 2 whole square, which is pi L square by 4. So frequency over here will be omega upon 2 pi. So area swept over here will be what? Area swept per second over here will be this will be pi L square by 4 into omega upon 2 pi, right? Okay. Now magnetic flux changed in one rotation will be this into B times this will be the magnetic flux over here. So it is V omega L square divided by 8. Okay, so this is the rate of change of magnetic flux over here, right? But the two ends will gain the same polarity, and because of that the potential difference will be 0, right? So correct answer is option 2. Question number 22, we have flux as 60 square minus 5t plus 1. So induced EMF will be minus d phi by dt, and if you divide it by resistance, you will get induced current, which is minus of 1 upon r into 12t minus pi. So it is minus of 1 upon 10 into 12 into 1 by 4 minus 5, which is equal to 0.2 ampere. Question number 23, we have light incidence angle. So this is also I. This will be 90 minus I and this will be I. So R is actually 90 minus I. So apply Snell's law over here. So this is mu1 sine I is equal to mu2 sine 90 minus I. So over here tan I will be mu2 upon mu1. So I will be tan inverse mu2 upon mu1, which is option 2. Question number 24. Vessel hai, the depth T is half filled with the oil of refractive index mu1 and other half is filled with the water of refractive index mu2. The apparent depth over here. So it is T1 upon mu1 plus T2 upon mu2. T1 is T by 2, mu1 is mu1 plus T2 is T by 2 divided by mu2 is mu2. So after solving this one, you will get apparent depth as this one. We have convex mirror, and this is question number 25. We have convex mirror, and focal length is 30 centimeter, and image is quarter size. Okay, quarter of the size of the object. Okay, so magnification is 1 by 4, which is f upon f minus u. So over here it is 1 by 4, which is 30 upon 30 minus u. So we have 30 minus u is equals to over here 120, and this will be u will be minus 90 centimeter, which is option 2. Question number 26, power factor is r upon z over here. So power factor is 3 upon under root of 3 square plus 4 square, which is 3 by 5, which is 0.6. Question number 27, we have variation of R, XL and XC with frequency in a series LCR circuit. Then for what frequency point the circuit is inductive? So for inductive, over here, if you look at it, so it should be inductive. That means XL should be greater than XC. Right, so at point C, XL is greater than XC, otherwise at point B it is equal, and at point A, XL is less than XC. So correct answer is option 3. Question number 20, we have transformers N1 300, and in secondary coil we have 150. Output power is 2200 kilowatt, and the current I2 is 10 ampere. So we can apply N1 upon N2 is I2 upon I1. So I1 will be I2 into N2 upon N1, which is 150 divided by 300, that is 5 ampere. Right, now output power is equals to input power. So output power is 2200 watt is equals to input power, which is V1 into I1, which is 5. So V1 will be 2200 divided by 5, which is 440 volts. So correct answer is option 2. Question number 29, in an LCR series circuit, AC voltage across R, L and C are 10, 10 and 20 respectively. Okay, so what is the total voltage across entire combination? So this is VL minus VC whole square plus VR square. So this will be 20 minus 10 whole square plus 10 square over here. So this is 10 root 2 volts, which is option 4. Question number 30. Consider the following statements. Through light of a single frequency is incident on a metal, the light of a single frequency incident on a metal, the energies of emitted photoelectrons are different. True. The energy of the electron emitted from inside the metal surface is lost in collision with the other atoms in the metal. This is also true. So both the statements are true. Question number 31, we have energy of an hydrogen atom in its ground state is 13.6 minus 13.6 electron volt. The kinetic energy and potential energy of the electron in the first excited state of singly ionized helium atom are. So first excited state matlab n is equals to 2. So over here energy is minus z square upon n square into 13.6 electron volt. So it will be minus 2 square upon 2 square into 13.6 electron volt. So energy over here will be minus 13.6 electron volt. This is total energy. Kinetic energy is minus of total energy. So it will be minus of minus 13.6 electron volt, which is 13.6 electron volt. And potential energy is 2 times total energy. So this is 2 into minus 13.6 electron volt, which is minus 27.2 electron volt. So correct answer is option 2. Question number 32. A radioactive material half-life is 10 minutes. So we have n upon n naught is equal to 1 by 2 times t upon t half. So over here, if you compare this thing, because we have total 600 and 450 nuclei are disintegrating, so remaining is 150. So we have 1 by 2 to the power 2 over here is equal to what? It is 1 by 2 to the power t divided by 10. So t will be 20 minutes. So n is 150 and n naught is 600. Question number 33. The condition under which a microwave oven heats up a food item containing water molecule most effectively is the frequency of the microwave must match the resonant frequency of the water molecule. So correct answer is option 2. Question number 34. In dominant mechanisms for current due to charge carriers in forward and the reverse bias PN junction are. So diffusion in forward bias and drift in reverse bias. what is the value of current in the circuit? So this PN junction is forward bias, potential difference, so it will offer 0 resistance. So potential difference across this resistor is 3 volt divided by resistor will be current, which is 0.01 ampere, which is option 2. Question number 36, we have three rings, each equal radius r, are placed mutually perpendicular to each other, having its center at the origin of the coordinate system. If the current I is flowing through each ring, then the magnitude of the magnetic field at the common center is. So at this center, we need to find magnitude of the magnetic field. So due to this will be, let's say, current is flowing like this. So magnetic field is along y-axis, which is mu naught I upon 2r j cap, plus due to this one, let's say current is flowing like this. So magnetic field due to this one will be mu naught I upon 2r along I cap. And due to this one, let's say current is flowing like this. So magnetic field will be along z cap, k cap. So it is mu naught I upon 2r k cap. So by finding the vector summation of this one, which is under root 3 mu naught I upon 2r, is the magnitude of the net magnetic field at the common center, which is option 1. Question number 37, we have circular coil of galvanometer has 50 turns and radius is 1 centimeter. The coil is placed in a radial magnetic field this and torsion coefficient is this one. Determine the deviation. So it is NIAB divided by K. So this is deviation, which is by putting all the values you will get as 30 degree. Next is 1 mole of an ideal gas goes from an initial state A to final state via two processes. It firstly undergoes isothermal expansion. So this is not isothermal expansion. This is not isothermal expansion. A to B, we are going A to B. So this is not possible. This is possible and this is possible. Right. And second is from 3 to recompression at constant pressure. So this is constant pressure graph. This is not constant pressure graph. So over here, correct answer is option 2. Question number 39. Particle moves from position R1 to R2 under the influence of this force. What is the work done? So delta R vector over here is R2 vector minus R1 vector, which is 11 I cap plus 11 J cap plus 15 K cap. So work done is F dot delta R. So it is 4 into 11 plus 1 into 11 plus 3 into 15, which is equal to 100 joules. Question number 40. We have a particle of mass 0.1 kilogram is subjected to a force which varies with the distance as shown in the figure. Initial velocity is 20 meter per second. What is the velocity at 12 meter? So by applying work energy theorem, you can write change in kinetic energy, which is half mv square minus half mu square is equals to work done. So area of F versus X graph will be work done, which is half. Base is this 12 plus 4, 16, and the separation between two parallel is 10. So we here half cancel. So you can take m common, which is 0.1. V square minus u square is 400 is equal to 1600 over here. So v square is 2000, and after solving this one, you'll get v as 20 root 5 meter per second. Question number 41. We have a spherical ball of mass m1 collides head on with another ball mass m2 at rest. The collision is elastic, that is E is equals to 1. Then the fraction of kinetic energy lost by m1 is. So v1 after the collision of this ball will be m1 minus m2 into u1 divided by m1 plus m2. Okay, plus 2 m2 u2 divided by m1 plus m2. So this is the kinetic velocity of the first ball after the collision. So fraction of kinetic energy lost is loss in kinetic energy, which is initial is half m1 v1 square minus final is half m1 v square, final is half m1 v1 square, which is this one, m1 minus m2 divided by m1 plus m2 whole square into v square divided by original kinetic energy, which is half m1 v square. So after solving this one, you will get fraction of kinetic energy lost as this option, which is 1. Question number 42. In figure, a spherical part of radius r by 2 is removed from a bigger solid sphere of radius r. Assuming the uniform mass distribution, shift in the center of mass will be. So if mass of the bigger is m, then a removed portion will have mass m by 8 according to the volume removed, right? So a new center of mass will be, let's say this is origin, so new center of mass will be um, m1 into r1 minus m2 into r2, which is at r by 2, divided by m1 minus m2, so it is 7 m by 8. Right, so this will be minus r by 14, which is option 2. Question number 43, we have uniform rod of mass m and length L is hinged at 1 and A. Initially it stands vertical. It is allowed to fall freely on the floor in the vertical plane like this. So it will be here after some time. What is the angular velocity of the rod when its end B strikes the floor? So loss in potential energy, which is mg into L by 2, will be gain in kinetic energy, which is half pi omega square. So I is ml square by 3 into omega square. So after solving this one, you'll get omega as under root 3g upon L. Next is question number 44. We have a coil of resistance 100 ohm and current is induced by changing the magnetic flux through it. What is the change in flux through the coil? So, EMF is d phi by dt, magnitude of EMF. So, over here d phi is E dt and E is equals to IR dt. So, that is d phi. Now, integrate it. So, it is R times I dt, and integration of I dt will be area under this curve, right? So, this is R into half into base into height. So, after this one, you'll get change in flux as 250 Weber. Question number 45, we have self-inductance EMF, induced EMF of a coil is 60 volt. When the current in it is changing from this to this, what is the change in energy of the inductance? So it is equal to L minus L di by dt, which is, or just a magnitude is L di by dt, which is 15 upon 0.5. So L will be 2 Henry. So change in energy is half L I2 square minus half L I1 square. So it is half into L I2 square is 25 square minus I1 square is 10 square. So after solving this one, you'll get change in energy as 525 joules. Question number 46, we have two transparent media A and B are separated by a plane boundary. The speed of light in medium A is this much and in medium B is this much. The critical angle for which a ray of light going from A to B is totally internally reflected is. So refractive index of A with respect to B is over here 2.5 V2 upon V1. So it is this much, which is 5/4. Right. So critical angle sin C is 1 upon mu, which is 1 upon 5/4, which is 4/5. So C is sin inverse 4/5, which is option 3. Question number 47. We have a small plane mirror is placed at the center of a spherical screen of radius r. A beam of light is falling on the mirror. If the mirror makes n revolutions per second, the speed of the spot of light on the screen after reflection from the mirror is. So when you rotate mirror by theta, the reflected ray will rotate by 2 theta. So again, frequency will be double. So frequency of the reflection will be 2n. So speed will be 2 pi into f into r, omega into r. So it is 2 pi into 2n into r, which is 4 pi n r, which is option 4. Question number 48, we have radio transmitter radiates 1 kilowatt power at the wavelength this much. How many photons does it emit per second? So number of photons emitted over here is P upon E. So it is P upon HC upon lambda, which is P lambda upon HC. P is 1 kilowatt, H is the Planck's constant, C is speed of light in vacuum, and lambda is 198.6 meters. So after solving this one, approximately the answer will be 10 power 30. Question number 49. The binding energy per nucleon of Li and He nuclei are this and this respectively. In the nuclear reaction given here, the value of energy Q released in mega electron volt is. So over here, it will be 2 times for He it is 4 into 7.06 minus for lithium it is 7 times 5.60. Right, so this is 8 into 7.06 minus 39.2 mega electron volt. So this is 56.48 minus 39.20, which is approximately 8.2, and this is 7. So 17.28 mega electron volt, which is option 1. Question number 50. In a plane electromagnetic wave, the electric field oscillates with amplitude this. Then the energy density of the magnetic field is. So it is same as that of the electric field, which is 1 by 4 epsilon naught E square. So it is 1 by 4, 8.85 into 10 power minus 12 into E square is 20 into 20. So this will be 100. So it is 8.85 into 10 power minus 10 joule per meter cube.